Hello everyone. Today we are going to discuss tungsten inert gas welding and plasma arc. So content of the slides are tungsten inert gas welding or gas tungsten arc welding and plasma arc. Tungsten inert gas welding or TIG. Tungsten inert gas welding is commonly known as TIG, in which tungsten electrode act as a cathode. A plasma is produced between the tungsten cathode and the base metal, which heats the base metal to its melting point. A filler metal can be added to the pool to complete the welding. We can see in the schematic that a power supply is connected to the base metal and the tungsten electrode. And tungsten electrode is welding slowly the base metal, and wire has been puddled into the weld puddle. The gas tungsten arc welding process may be used to weld most metals and alloy in any position with or without use of filler. Because of the smaller heat zone and weld puddle, with the excellent shielding effect of the gases used, the weld produced are often stronger than the welds made with other processes. Although GTAW is slower and produces smaller weld beads than SMAW or GMAW. It is often the process of choice for welding thinner sections, aluminium, especially metals, and stainless steel. If we compare TIG with the MIG, we can have some points like MIG welding is known as metal inert gas welding, whereas TIG is tungsten inert gas welding. In MIG welding, metal rod is used as electrode and workpiece used as another electrode. In TIG, tungsten rod is used as electrode. It is a gas-shielded metal arc welding. TIG is a gas-shielded tungsten arc weld. In MIG welding, continuous feed electrode wiring is used, which are fast. In TIG, welding rods are used, which are slow in speed. In MIG, the welding area is flooded with a gas which will not combine with the metal, whereas in TIG, gas is used to protect the welded area from atmosphere. MIG can be MIG can weld materials such as mild steel, stainless steel, and aluminum. A range of material thickness can be welded from thin gauge sheet metal right up to heavier structural plate, whereas TIG weld whereas TIG weld can weld things like kitchen sinks and toolboxes. Pipe welding and other heavier tasks can also be performed. You just need to have a unit that is capable of putting out amount of power that you need. MIG requires consumable metallic electrode, whereas TIG is used as non-consumable tungsten electrode weld. So TIG is a non-consumable electrode weld. Electrode is fed continuously from a wire reel. It, whereas TIG does not require electrode feed. MIG can be used with DC reverse polarity, whereas TIG can be used both AC and DC. In MIG, filler metal is compulsory to use. In TIG, we can use or we may not use the filler metal. MIG welding MIG welding can weld up to 40 thick metal sheet, whereas TIG welding can weld up to 5 thick sheet. MIG is comparatively faster than TIG welding. TIG is a slow welding process when it compares to the MIG weld. Next, plasma arc weld. It is a kind of non-conventional welding process. In this process, the hot ionized gases are known as plasma. When a sufficient amount of energy provided to any inert gas, some of its electrons breaks free from its nucleus but travel with it. After the electrons leave, the atoms are converted into hot ionized state. It is most common state of matter which is known as fourth state of matter. These ionized atoms have high heat content which is further used to join two plates. This is the basic principle of plasma arc welding. Plasma arc welding is extended form of TIG welding in which a non-consumable tungsten electrode is used to produce arc. This arc heats up the inert gases which are provided from inner orifice around tungsten electrode. The heating temperature in PAW is about 30,000 degrees centigrade, at which the gas converts into ionized form. This hot ionized gas further used to create a welding joint by fusion. This is a schematic which is showing the principle of plasma arc welding, where we can clearly see the shielding gases are shielding the environment, and a plasma is generated to weld the surface. Now we are going to discuss the equipment used in plasma arc welding. In plasma arc welding, we need a welding power supply, which comes from a high frequency generator, an electrode, orifice gas, cooling water, shielding gas to protect the environment, and a pilot arc power, which is connected to both workpiece and the electrode. Now we are going to discuss the advantages of the PAW or plasma. Plasma arc welding has improved arc stability at very low current. It has greater energy concentration and the higher welding speed. It has narrower beads with less distortion, as much as about 50%. Tungsten electrode is recessed inside the torch. There is no danger of tungsten inclusion in plasma arc weld. In PAW, increased torch standoff distance makes the weld pool much easier to control. In plasma arc welding, arc column is cylindrical and easier out of position welding can be done. Disadvantages of plasma arc welding. It has narrow constricted arc. PAW has little tolerance for joint misalignment. Manual plasma torches are heavier than TIG torches, and it is difficult to manipulate. It has more complex equipment than the TIG welding. The equipments are expensive also. Except aluminum alloys, keyhole plasma is restricted to the flat position. In plasma arc welding, torch must be well maintained for consistent operation. The whole process is kind of costly. And these are the references for the content which are showing in the slide. Thank you.